Okay. So as a company, we look to be the best at buy versus build. So you've got a custom trading system, for example, and you want to have a custom field, but you don't want to build the whole thing from scratch. So we provide a lot of the core infrastructure you need, products, and even consulting to back that up. So you're not taking on all the risk yourself, but you still get the custom feel. You still get to develop your USP. What is going to make your project different to anyone else's? But a lot of the common elements that every trading system needs, we provide that either as expertise or as actual product. And that reduces the risk of the project. It's more likely to be successful, delivered on time, and be easy to maintain once it's developed. So we have 16 tier one banks and exchanges as paying clients. We have over 200,000 different unique IP addresses who use our software. And from somewhat anecdotal evidence, we find that at least our open source products are used in at least 80% of banks already. So maybe if you're not familiar with Chronicle, you might find that actually it's one of the libraries your organization is already using. So two areas that we're seeing development in is greater use of the cloud. I mean, that obviously was a hot topic a few years ago, but in reality, what we found was that trading systems sort of held back and said, well, look, we need a control over our environment. So we need to be on premises. But more recently, we've seen more of our clients shift even trading system functionality into the cloud. And in particular, we've done quite a bit of co-development with AWS to investigate how their systems work with our functionality and our componentry and running benchmarks, and how can we deliver very similar performance for cloud machines as our clients are used to for on-premises. So here's an example of a market data distributor, which you can see is low latency. This is a metal host, right? So it's still bare metal, but an untuned metal host running on AWS, you get very good results up to the 3 nines. And we have a product called Tune, which will smooth out the jitter even further, well into the 5 nines. We have another product, as I mentioned earlier, we've got Chronicle Q. This does very well up to around the 4 nines, but for higher nines, again, our tuning product helps smooth that out. But nevertheless, this sort of illustrates that we are both investigating and supporting how to provide very consistent latencies for cloud environments, because we see clients shifting to actually doing this. In the past, they were always saying, well, if we go to the cloud, how will this work? Are we future-proof? Whereas now we're seeing clients actually doing it. So this is another product called Ring Zero, and what that does is deliver extremely low latencies because it's just passing between processes or threads, and it's not attempting to persist each message. But again, even in that situation, Tune does help. But if you're interested in the lower nines, then you can still get very good results on a bare metal AWS machine. I've included this slide, which is the only slide that's not from us. This is actually from a client. So one of our clients is using us to, as a part of their strategy to get high performance, but in the cloud space. And they're using our software to deliver the data storage and performant data storage of all over their events and key data, rather than use some of the other AWS services, which weren't designed for low latency, but they're still on premises and in the cloud. And the reason they're doing that in many cases is because the exchange that they're connecting to is also in the cloud. So you won't, even though on premises or colo can get the best results, if the exchange you're talking to is in the cloud, you really need to be in the same cloud it is. You won't get a better result in a different cloud or off cloud, because you're paying the latency cost of going out of the cloud. So another area we see as quite critical to the success of the projects that we work with is that there's a shortage of skilled developers. And that is to both implement projects, but also start new ones, like a major new project. And often clients they look to hire within because they can't hire externally in many cases. And so we have a number of strategies about skilling up the developers you do have that may have a lot of experience in understanding your organization, but not necessarily have the skill set for consistently and reliably deploying a low latency trading system, or basically, on generic terms, an event processing engine. So what we look to do is find ways of improving the outcomes of these projects by producing quality components, but also having a methodology around them so that you'll utilize them effectively. And this results in fewer bugs, reduced cost and maintenance, faster development cycles. So that's one of the things I'm very keen on, is reducing development time, iterative development time, and achieving shorter time to market for new features. So one of the things that's really useful, and it's not a very exciting topic, but one of the things that's so useful is behavior-driven tests. The reason that it's useful is you can focus on what's the actual core functionality, and strip away all the accidental complexity. So accidental complexity impacts both your performance, because your application is doing more things than it needs to. It impacts your development time because you're developing things that aren't actually required. They don't satisfy some business requirement, but they also become a maintenance overhead. So your application, your project loses development velocity after you go into production, because you're having to deal with a lot of complexity that actually wasn't required in the first place. So one of the key things about developing these applications is that at a high level, it should read like a story that matches a narrative that a business person would appreciate or understand. And so it should read like a story and not be a puzzle of pieces that you put together to try and build a picture. The approach we take is to use behavior-driven development, where you describe at a high level all the events that come in and all the events that can come out of your processing engine or your trading component. And we write this in YAML because it's a human readable format, and it fairly naturally translates to what is the actual event and method calls that will happen in your system matching these events. Now, just as a nicety, we add in things like comments, and you have a lot of these fields are human readable, but in reality, under the bonnet, they will get turned into a long value for efficiency purposes. So, for example, the timestamp here is actually going to be internally in binary format, is a long, but for testing purposes or dumping it, you can see it as text to make it more readable. One of the benefits of using YAML is that when you have a test that fails, you can very easily see why it failed. And then hopefully that also shows you why, what is your course of action to resolve this in a fairly simple manner. So one approach that works quite effectively when this is appropriate is to just overwrite your results. So by overwriting results, you can just maintain a large number of tests and say, I've changed the functionality. I now need to update all the tests to reflect that this is an accepted change. You can then review that change when you check it in or as part of a PR. However, if there's an unexpected change, a genuinely unexpected change, then maybe you've broken something. But you can see quite clearly, well, where's the discrepancy? Because it's now doing a text comparison. In this case, it expected an account with a larger number, and it came through as a smaller number. So because these are data-driven tests, we can manipulate those tests to explore all the ways things can go wrong. So one of the most tedious things to do is to say, well, what if this value is wrong? What if that value is wrong? What if the messages are out of order? All the different variations or this field is blank or whatever. So you can actually explore all of those programmatically without having to write all those additional tests. And so what this is doing is saying, well, these are all the results that you get if any of these conditions are the case. In this example, I started with 3 tests that I'd handwritten myself, and it generated all the different results, all the ways things can go wrong, and explores all of those programmatically without you having to write them or maintain them. So that then allows you to get a high code quality without having to do a lot of the work and the maintenance yourself. So one of the biggest shifts here is this is a different approach to what people may be used to, but it is very effective and very efficient way to develop your system. Taking it further, because it's text-based, you can actually feed it into an AI and ask it to generate another test which is similar to that test. So in this case, I asked it to generate a different test based on a test I already provided. In reality, it didn't change it very much in this example, but nevertheless, it is able to do things like maintain the comments, and it can do a remarkably good job in certain cases. So this will allow you to develop new happy path tests, as well as the other tool developing all the way things can go wrong. In fact, I took it a little bit further and I said, can you generate me 20 more accounts? So this is a simple account creating example. And instead of actually just generating a very long YAML, it actually created a script in a thing called Ginger. And that script then allows you now to create 20 accounts and see that all does what it's supposed to. And I didn't have to write this either. So the last 2 examples, I didn't actually have to write myself. I could just naturally use AI without really seeding it with anything. It could naturally handle that data format. And that's the sort of thing you want, is that it's easy to naturally handle your data through other tools without any kind of special handling. So it generated more tests and was able to achieve pretty close to 100% code coverage. Some of these are mains, so not all the code is run because it's not part of a test, but you get very good code coverage just through a lot of it is just generated. You're not having to run it yourself. Now, a more realistic example is our EFX book builder. So we have a component which takes in FX data from lots of sources, EBS, Reuters, CurrentX, and combines them together. I identified 57 tests for which this technique of looking at all the way things can go wrong is appropriate. So we actually have higher code coverage, but some of the tests weren't appropriate. But if you generate every possible variation, you can get an enormous number of tests, but it takes a very long time and it only increased the code coverage by 3%. So you don't want it to take too long, because if your tests are taking too long, it means your development cycle is much longer, your productivity goes down, and it takes you longer to change something and then see whether you've broken it. However, there's a very simple strategy that it uses to cut that down substantially. What it looks to do is, again, because it can manipulate the inputs and outputs very simply, it can just look for tests that produce a new output that no other test has produced. So it runs through the standard tests and then starts going through the generated tests. And if it doesn't generate a new message that no other test has already generated, it drops that test and says, well, that didn't add any value. And in fact, using this approach, I achieve the same code coverage and still only takes about half a minute to run all the tests. So this is some of the power of taking this approach, is that you can write tools to manipulate the tests so that you don't have to maintain them all yourself. And also then moving on to Rust. So again, this is a bit like the cloud. This is something we've seen interest in the past, but it's not something that people have really approached us that say that they'd like to use in anger. However, in the last little over a year now, we've seen a shift from curiosity and interest and people wanting to play with it to people actually using it in production. And in fact, Rust being for that project, the primary language. And then other languages might need supporting, but the core part of the system was being developed in Rust. And in fact, our matching engine is, we have a version in Rust that's very close to production. Last but not least, another area we're looking at developing, particularly over the next year, is making the tools as frictionless as possible to adopt. This helps with the evaluation process, but it also helps with taking it later when you have to do the actual integration with all your different existing products. So we get a lot of migrations from Quick Fix to Chronicle Fix, for example. It doesn't take that long, but there is value in making that even shorter and simpler to do.